everyone. In the last class we have discussed about the plane mirror, characteristics of plane mirror, concave mirror and convex mirror. In convex and concave mirror we have dealt with the terminologies which come under the concave and convex mirror, right? So today we will discuss about the image formation in the plane mirror, concave mirror and convex mirror. Okay, so first we will deal with plane mirror. Hopefully today we will try to cover the image formation in plane mirror, and also we will see the characteristics of the image formed in the plane mirror. Okay, and this is again a part of light chapter itself. Okay, which is chapter number 10 in NCERT CBSE. Okay, so like yesterday we have seen that, let me draw a plane mirror. As you all know that plane mirror, okay, so first let me draw a plane mirror and let me take a point object here. Let me take the object at this point, okay, point object, and this, first of all I'll point all this, the normal and the angle of incidence and angle of reflection, so that it would be easy for me to draw the diagrams. Okay, so I have drawn a line because we know that a plane mirror is flat, the reflecting surface of the plane mirror is flat, so I have considered this one, and on the other side I am going to shade it so that, to show that this shaded part is non-reflecting surface. Okay, and this I'll name by M dash. Okay. This is the aperture. Aperture means what? The reflecting surface is called as aperture. So here this is the plane mirror, okay, and M dash is the aperture, that is the reflecting surface of the plane mirror. Okay, and here I have taken the object O, the point object O. Okay, so let me find out to what distance it is, and let me make a point on that side also. So it is 6.15. Okay, so let me take here also the same on the other hand, just in order to draw correctly. Okay, here somewhere. Okay, so now what I am going to do is I am going to draw the incident ray. Okay, now let me take first that the light is first light ray. Okay, whenever the light falls onto this object O, okay, this object O, so let me assume that the first ray falls at an angle of 90 degree. Okay, first it falls at an angle of 90 degree. The light ray is made to fall at an angle of 90 degree, and this will be extended beyond. This is extended beyond. Okay, so this is the incident ray. Okay, as it is incident in perpendicular, as this incident ray is perpendicular to the surface of the mirror, so the reflected ray will be along the same path. Okay, along the same path of incidence. Is that clear? So this is the incident ray. The light is made to incident. Okay, this, let me take this point of incidence as O here. Okay, so OA is incident and AO is the reflected ray. Since the angle of incidence, okay, the light ray is projected at right angle at 90 degrees onto the surface, so it is going to reflect back in the same path. It is going to reflect back in the same path. It is going to reflect back in the same path. Hope this is understood. Now next, what I am going to do is, now I will draw the reflected ray. Okay, now if I take, this is 90 degree, right? So I will draw first a normal. Now let me take a point here, and I will draw this incident ray, one more incident ray. This is incident, okay, this is incident at an angle, okay, this is incident ray. So first one at right angle and this is at an angle, okay. Now I'll draw the normal ray. And from here I am going to draw the reflector. As in this incident ray hits onto the mirror, it is going to reflect back. It is going to reflect. And this is the reflected ray. This is the reflected ray. So one incident ray is OA, the second incident ray is OB, and BC is the reflected ray. Okay. The first one is OA is the incident ray, which is incident at an angle of 90 degree, and it is going to reflect back in the same path, because whenever the light ray falls at an angle of 90 degree onto the surface, making an angle 90 degree at the surface of the mirror, the light ray is reflecting back in the same path. The second ray, that is OB, is incident at an angle, okay, at an angle. So now next here you could see it is reflecting back with the same angle, okay. So since this is the normal, so this is the angle of incidence and this will be the angle of reflection, and this, let me call it as N. So NBC is the angle of reflection and OBN is the angle of incidence, okay. So here the angle of incidence will be equal to angle of reflection, that is OBN is equal to NBC. Is that clear? Okay. So now what we want, the image is formed where these reflected rays are going to meet. So one reflected ray I have already extended here. The reflected ray is extended here and that is beyond the mirror. Okay, that is virtual. This ray is virtual. Here also this reflected ray I am going to extend, because here if I extend this reflected ray and this they cannot meet, right? So we have to extend on the other side, that is behind the mirror. So if I extend behind the mirror, so let me see where they are going to meet. This one I have to extend a bit. Clear? Okay. Now you could see here that the reflected ray, okay, if I name it as O dash, okay, if I name it as O dash. Now you could see here this OA is the incident ray and AO is the reflected ray. OA is the reflected ray, right? So this reflected ray OA, okay, if you are going to extend in this direction, okay, and this reflected ray BC, if you are going to extend, they are not going to meet at any point of time, right? So what we are doing is we are extending on the other side. So this AO reflected ray is extended on the other side and this BC reflected ray is extended on the other side, and when they are extended we found that they are meeting at point O dash. They are meeting at point O dash. So this O dash, where these two reflected rays are meeting, okay, so that point, that intersection point is where the image is formed, okay. So here O dash is the image of object O, okay. So object O, what it is doing, if at all they ask you to define object, so object is a device or is a substance, okay. When the light falls on that object, it is going to reflect the light, okay. Because of that reflection, what is going to happen, image is formed, and this image is an optical appearance of the reflected rays. Is that clear? So O dash is the image. Now you could see here, what you can infer here is, you could see that if object O is kept in front of the mirror and we are getting image behind the mirror. We are getting image behind the mirror, which means that the first characteristic of the image formation is behind the mirror, okay. The image is formed behind the mirror. That is we call it as virtual image. We call it as virtual image. Okay. Now, second point. Now you could see, if you measure the distance AO and AO dash, if you measure OA and O dash, here I'll write it as OA and O dash. Okay. OA will be equal to AO dash. That is, OA will be equal to AO dash. That means the image, at what distance the image is kept in front of the mirror. Okay, so the image will be, here it is, if I measure, it is 6.15. Okay, so if I measure on the other side, let me see. What? Okay, it is almost like 6.5. Let me find it once again. Okay, it is 6.25, and here we are getting almost. So it's almost a slight difference is there. Okay, so maybe because of the angle. Okay, so it should have come here at this point. So this will be the, so almost it is going to be at an equal distance. Okay, the image formed in the plane mirror will be at same distance as that of the object from this mirror. Okay, that means at what distance the object is placed in front of the mirror, okay, the image is also formed at same distance behind the mirror. Okay, so OA is equal to OA dash. That means distance is same of image formed behind the mirror. Distance is same. Okay, the distance is same of image formed behind the mirror. Instead of this, we'll write in a simple way. The distance of the object in front of the mirror is same as that of the image formed behind the mirror. Okay, so it's not that like what the sentences that I am using that you have to use the same sentence. You can write according to your comfortability and in your language. Okay, the way you use the formation of sentence. Okay, so you can also write that the object distance and the image distance are equidistant. Okay, or the object and the image formed are equidistant from the mirror. Okay, from the point of mirror you can say, or from the surface of the mirror you can say. Okay, so basic thing that you have to understand is, in the first point you have to understand that the image formed is virtual image in the plane mirror. So what is that virtual mirror? Only virtual images formed. Okay, no real images are formed in the plane mirror. In the plane mirror you get only and only virtual images. Virtual images that cannot be caught in the screen. Okay, so that is the reason the image is formed behind the mirror. Okay, as the image is formed behind the mirror, that is an illusion, right? That is not a real image. Okay, so it is not caught on the screen, it is behind the screen. So the first point is, the first characteristic is, it is the virtual image, and the second point is the distance of the object and the image formed are equal. Okay, they are at equidistant from the mirror. Okay, that is the second characteristic. Then what is the third characteristic. What is third characteristic? You could see here, okay, that is, so the image, okay, so whatever the image, the size of the image would remain same. Okay, so here this is a point object, so whatever the size of the object is, whatever the diameter that object has here, so the diameter will be same. If it is in the length, if I have kept the object here, the marker, then the same length, the same size of the marker would be appearing in the plane mirror. Okay, so this is the point object I have taken. If you take the finite object, okay, so when you keep this one, okay, mirror marker here, so one ray will be here and the other one will be here. From here, one more ray, okay, one more incident ray which is perpendicular to the surface of the mirror, and one will be at an oblique you can take and you can reflect it so that they'll go and meet at this point. Then you can draw the image. Okay, so you will be getting the same size as that of the object. So the image size would be same as that of the object. Is that clear? Okay. Yes. Next point. Okay, and the image would appear erect. So all virtual images are erect. Okay, so third point. Okay, third point, if I have to write, let me write it here. Okay. So third point is what? So third point is the size of the image is same. Size means height of the image. Okay, so height of the image is the same as that of the object. So here, as we have taken point size, you can say diameter. Okay, here the size means dimension is diameter or the height. If you are taking this marker, then you will say height of the object. Is that clear? So if you are taking the point here, point, or if you take suppose if you hold this like this, okay, so then you find that the diameter of this object would be same. Okay, so the size of the, so in general we say size of the image is same as that of the object in the plane mirror. Okay, now the fourth point is, as we said, that the image formed will be erect. Suppose if you are holding this marker, see the cap is upward, right? So if you are holding in front of the mirror, then you see the image in this way only. Erect image you will find. Okay, that is the marker. This will be side up only. Okay, it is not going to be inverted. It will be side up. Okay, so it will be erect. We call it as erect. The image is erect. That is side up. Okay, the side will be up. So if you are standing in front of a mirror like this, if you are standing in front of a mirror, okay, then you would see the exact copy of yours, but not inverted. It will not be upside down, that your head will be down and your legs will be up. Okay, it is not going to appear like that. It is going to appear the way you are standing. Okay, erect. The erect image, that is called erect image. Okay, so erect image is formed in the plane mirror. Always virtual and erect. So all virtual images are erect. So you can write here it as virtual and erect also. Okay, you can, in the first point itself you can write virtual and erect image is formed. Clear? So remember one thing, all virtual images are erect. Okay, all virtual images are erect. Then what happens? What is the other point that we have to discuss here? Okay, so we have discussed all the 4 points. Okay, the last point is that the image is laterally inverted. Okay, laterally inverted. What do you understand by this laterally inverted? Lateral means side, inverted is opposite. Okay, so here inverted, as I said, inverted, it is not upside down, it is sideways. Okay, suppose if it is right side, then in the mirror it appears left side. So the left hand appears right and the right hand appears left. So it will be not upside down. Inverted means not upside down. Lateral means sideways. Okay, side, left side will be right side and right side will be left side in the mirror. The image of the object. Suppose if you are raising a right hand, then in the mirror it will be laterally inverted. That is, the side will be inverted. That means if you are raising right hand, the left hand, you feel, right, that left hand is being raised. Okay, that is called as lateral inversion. Okay, here the image will be laterally inverted. Okay, so suppose if you write, if I take this as a plane mirror, okay, and if I write P, if I hold P, then the P appears to you as like this. Okay, the size is also same, right? Okay, I hope. Okay, so the distance between these two will be same. Okay, the image object distance from the mirror and the image distance from the mirror will be equal. Okay, they both are of same size. Okay, they are virtual and erect. It is virtual and erect. The image formed is virtual and erect. Virtual because it is behind the mirror. Erect because the same side is up. Laterally inverted because it is side is opposite. Here it is onto the right hand side. This P, this curve, and this curve is onto the left hand side. Okay, so that is the reason they write ambulance. Okay, ambulance is written in reverse direction. Okay, so if you write ambulance, like this, then you would be seeing opposite of this one, right? You will not be able to read it correctly. So what they write? They write laterally inverted. How they will write? I'll write it like this and show you. A M B U L A N C E. Ambulance. Okay. So when this is written, if this is a mirror here, okay, just assume, dear children, if this is a mirror, okay, if this is the mirror, okay, sorry. Okay, so this is the ambulance. Okay, this is the reflection of this ambulance. So if this is written laterally, this is laterally inverted. Okay, this is written in opposite way, right? So when you see this in the mirror, okay, this appears to be ambulance like this. Correct, you can read it correct. Is that clear? Okay, so right, so here it is from right to left, so here it is from right to left. This right appears left, okay, and the left appears on the right side. Is that clear? Hope you understood what you understand by lateral inversion. Clear? Okay. So at home you can try. Okay, I have taken a point object here. What you can do is you can take the finite object here and you can draw one line. You can do one thing, that you can draw a line here so that it would be a finite object. So already you got, so here this is the object. So what you can do, you can extend this line here and you can draw, let me take up to here. So one incident ray will be at right angle and you can draw the extended reflected ray. So this is incident, this is reflected. You can draw the extended reflected ray. So one more you can draw from here. Okay, from here you can draw one incident ray. I'll just show you roughly. You can try at home. So if you draw this, okay, from here, sorry, from here, because this is the object, right? So from here, if you draw, okay, if you draw here, this is incident ray, and what happens? this will be reflected ray. This will be reflected ray. So when you extend this one, okay, straight line, okay, when you extend, so you find that it is here, right? You get this, you can join these two. You can draw and you get the image, okay? So these two, okay, these two reflected rays, okay? These two reflected rays are meeting at this point, and here these two reflected, and when you join that line, you could see that the virtual image, okay? So earlier one was the finite one, a point object, okay, and this is the finite object we have taken. So suppose if I keep the marker here, okay, so the image of this will be formed here. Clear? Hope this is clear, okay? So try and solve the problems and try and understand the characteristics. We have 5 characteristics of the plane mirror, okay, which we have discussed. So you can go through this and you can understand. It's very simple, okay, it's not much difficult to understand. Only thing is you have to imagine and you have to understand the concepts. The main thing is in physics, okay, in physics, mathematics, any subject you take, you should try to understand the topic. You should try to understand the concept of the topic so that it could be clear to you, okay, so that you can remember. So while remembering also, you can relate it to some other things, examples, and then you can remember it for a longer time. Okay. So if you learn with the concepts, then that will be very clear. Okay. Fine. Now moving on to the next topic. That is concave and convex mirror. First we'll go with the concave. Okay. Concave mirror. Concave mirror. So yesterday we have seen that the concave mirror appears to be like the mirror or the spherical. It is a part of a spherical mirror, right? Concave mirror. So the part of a spherical mirror, concave mirror is a part of a spherical mirror. Okay, is a part of a spherical mirror. So if I have to take it, so now this is the concave mirror, right? This is our concave mirror, M dash. Okay. This is curved inwards, okay? This is a spherical mirror. Concave mirror, this is the concave mirror, right? This is the concave mirror. So concave mirror is a part of a spherical mirror, okay, whose reflecting surface is curved inwards. Is that clear? Yeah? See here. Concave mirror. This is the concave mirror. Concave mirror is the part of a spherical mirror whose reflecting surface, whose reflecting surface is curved inwards, like this, is curved inwards, okay, is called as concave mirror. This concave mirror, yesterday we have seen concave mirror is also called as converging mirror or magnifying mirror, okay. So now, yesterday we have seen that the center of this sphere, we call it as center of curvature, and it is denoted by C. And center of this reflecting surface, that is M dash, the center of the aperture M dash, we call it as pole, and it is denoted by P, capital P. When you join these two, okay, center of the sphere and that is center of curvature and the pole, then we call it as this length, we call it as radius of curvature, okay, and that is denoted by CP is denoted by capital R, okay. And center of this one, suppose if I extend this line, okay, on both ways, if I extend this line, okay, if I extend this line, this is XY, this is the principal axis, That means the line passing through the center of curvature, the straight line passing through the center of curvature and the pole is called as principal axis. It is xy. Okay, it is xy. Then whenever the rays are there, okay, next if I have to say, this is the radius of curvature, this part is the radius of curvature, R. This is the radius of curvature. Midpoint of this one, okay, we call it as F. F is the point where the reflected rays are going to converge. Okay, so whenever you draw the rays here, okay, so they are going to reflect and pass through the focus. Okay, so these are going to pass. So that F, that principal focus, is the midpoint of radius of curvature. Okay, and the distance from this F to P, that is from the principal focus, the distance from the principal focus to the pole is called as focal length. Focal length, and it is denoted by small f, lowercase f. Clear? So F is the focal length, and yesterday we have seen that R is 2 times of focal length and F is half of radius of curvature. For that you can read the previous previous class video. Okay, hope you have understood this one. Okay, so this is all about the concave mirror. Okay, so similarly the convex mirror, whose so in the convex mirror what happens? This is your non-reflecting surface, and here the reflecting surface, this is the this is the aperture. Okay, so this is the concave mirror, this is the convex mirror. Why is this called as convex mirror? Why do we call this as a convex mirror? Why? Because the surface, the reflecting surface is bulging out. Okay, is bulging out, or the reflecting surface is curved outwards, so we call it as convex mirror. So in convex mirror what happens? The reflecting surface is curved outwards. Okay, and again everything is same here. So here again the center of this sphere, as this convex mirror is also a part of a spherical mirror, and the center of that spherical mirror we call it as center of curvature. It is denoted by C. Clear? Okay, and center of this aperture we call it as pole P, and when you join this one, okay, this is called as radius of curvature. Okay, P to C, this is the radius of curvature. This is the radius of curvature. Okay, CP is the radius of curvature. Since the radius of curvature is behind the mirror, we call it as virtual radius of curvature, and here since it is falling inside, okay, so we call it as, that is in front of the mirror reflecting surface, so we call it as the real radius of curvature in concave mirror. Okay, so radius of curvature, the focal length, the principal focus, and then the principal axis, all are real in the concave mirror, whereas in the convex mirror they are virtual. Okay, and one thing you have to remember that we will be dealing with, okay, the next classes, but still understand that the convex mirror and the plane mirror are the two mirrors, okay, which will always and always obtain or form virtual images only. So no real images are formed in plane mirror and convex mirror, but whereas in concave mirror is a mirror in which we get both real and virtual images depending upon the position of the object, Hope this is understood. Now moving on to the next topic. Okay, is it clear? I hope, as and when you just go through this video, hope you will be understanding. Hope you it is clear to you all. Now moving on to the next topic, that is rules for ray diagram. Okay, rules for ray diagram. And no matter any mirror, whenever the light is made to fall at right angles, okay, at right angles, then the reflected ray, it is going to reflect back in the same path. Okay, next topic that we have is rules for ray diagram. Rules to draw ray diagram. rules to draw ray diagram. So what is the first rule? Okay, suppose let us talk about the concave mirror itself. If this is the concave mirror, why? Because the reflecting surface is curved inwards. Okay, and center of this, let me take it as P, that is pole. Okay, and let me draw the straight line. Okay, and let me point this as center of curvature C. Okay, and if I draw a straight line passing through the center of curvature and pole, that is principal axis xy. Xy is the principal axis, C is the center of curvature, CP is the radius of curvature. Is that clear? Now, next what I am going to do, the first rule, what he says, in the first rule, whenever, and the midpoint of this one is F. Okay, I'll write it as F. F is the principal focus. So whenever the light ray is parallel, whenever the light ray is parallel to the principal axis, okay, whenever the light ray, that is incident ray, this is the incident ray, whenever the incident ray is parallel to the principal axis, okay, then the light is going to reflect, and this reflected ray must pass through, the reflected ray must pass through the principal focus. The reflected ray must pass through the principal focus. Okay, this is the first rule. So what is the first rule? When the light ray incident, okay, at parallel to the principal axis, when the light ray which is incident, that is incident ray, let me call it as incident ray. Okay, when the incident ray is parallel to the principal axis, you can see parallel here. So when the incident ray is parallel to the principal axis, okay, then the reflected ray must pass through the principal focus. Must pass through the principal focus. Okay, so this is. So to make it easy for you people, I'll take the second rule, exactly the reverse. Exactly the reverse. So what is happening here? When the incident ray is parallel to the principal axis, when incident ray is parallel to the principal axis, the reflected ray is passing through the principal focus, or the reflected ray must pass through the principal focus. Okay, so what is the reverse of this one? What is the reverse of this? That is, whenever the incident ray is passing through the principal focus, whenever the incident ray is passing through the principal focus, then the reflected ray has to be parallel. Right? Okay, let me draw that one. This one. If this is the concave mirror, this is the concave mirror. Center of this concave mirror, let me name it as P, pole, and let me take one point here as C, center of curvature, and midpoint I'll name it as F. Okay. So you have to take the proper dimensions. Okay. So here, and the line passing through the center of curvature and the P is principal axis XY. Okay. F is the principal focus. Now, what was that? Whenever the light ray, whenever the incident ray passes through, so what I am going to do? I am making the incident ray to pass through the principal focus. Okay, so incident ray is passing through the principal focus. Okay, so here incident ray is passing through the principal focus. So whenever the incident ray passes through the principal focus, then the reflected ray must be parallel. Then the reflected ray must be parallel to the principal axis. Is that clear? Yes. So here what happened? The incident ray was parallel to the principal axis and the reflected ray is passing through the principal focus, and exactly opposite of this, when the incident ray is passing through the principal focus, the reflected ray is parallel to the principal axis. Okay, this is the second rule. Okay, so now third rule. Okay, to make you understand third rule, just I will be wiping it off. Okay, so if you want, you can copy or you can understand. Okay, or let me see if I can draw that side, that could be visible to you all. Okay, so let me erase this bit and let me write it as Y here. Okay. Okay, is that clear now? Next, now the third rule I will take. Okay, again take the concave mirror. Okay, take the concave mirror. Okay, then center of this be P. Okay, center of this, that is pole, center of the reflecting surface be pole. Okay, then this be Y and X, because if I take C as center of curvature, the line passing through center of curvature and the pole is principal axis, and midpoint of CP is F, that is principal focus. Okay, the third rule, what is the third rule? Okay, third rule is that if at all the incident ray is passing through the center of curvature, okay, if the incident ray is passing through the center of curvature, then this incident ray which is passing through the center of curvature, when it falls onto the mirror, reflecting surface of the mirror, it makes 90 degree. It makes 90 degree. So whenever the light ray is falling at an angle of 90 degree, that means it is going to reflect back in the same path. So here it is going to reflect back in the same path. Is that clear? Okay, this is the third one. So when the incident ray passes through the center of curvature, the reflected ray passes along the same path. Is the third one. Then what is the fourth one? Okay, fourth rule is that again center, let me take it as P. Okay, I think by now you might have understood. Okay, so you will be able to draw the ray diagrams, and what all that you have to draw, I think you have already understood. Okay, so one again and again, even if I don't explain also, you will be catching those lines. Okay, so that is really very good. So now what the fourth rule, what is the fourth rule? Whenever the incident ray hits at a pole, whenever the incident ray hits at a pole, okay, pole, whenever the light, when the light is incident at pole, okay, it is going to obey the second law of reflection. What is second law of reflection? That the angle of incidence will be equal to angle of reflection. So the light ray that will be reflected, the light ray that is reflected would be at the same angle as that of the angle of incidence. Okay, so this is the reflected ray. So here this will be, okay, so here the angle of incidence will be equal to angle of reflection. Is that clear? So whenever the light ray is incident at pole, okay, the reflected ray makes an angle equal to the angle of incidence with the principal axis. Is that clear? So it is going to obey. So whenever the light ray falls at pole, whenever the light ray falls at pole, okay, or incidents at pole, what is going to happen? It is going to obey the law of, that is second law of reflection. That is, it is going to reflect back with the same angle of incidence. Is that clear? Hope all the rules are clear. Okay, in the next class, okay, I'll come up with the image formation. Okay, that would be the next topic. Okay, so hope you have enjoyed this class. Okay, thank you so much, and I'll come up with the image formation class video in the next video. Thank you so much.